Okay, so we're going to be going over section 9.4, ellipses, and there are lots of formulas for you to use, and so I'm going to illustrate what an ellipse is and the different parts, and then try to help you organize it into a table so you can find your formulas easily. Okay, so there's two different types of an ellipse. There's a horizontal ellipse, and there's a vertical ellipse. So horizontal means that it's going to be laying horizontally. Vertical is going to be more up and down. Okay, so really all the parts are the same, whether it's horizontal or vertical. It's just if it's vertical, it's been rotated 90 degrees, kind of like the parabola. When you have a vertical parabola or a horizontal parabola, they just rotate it over. Okay, so the way that you get an ellipse is from two foci points. So actually the definition for an ellipse is the set of all points in a plane so that the sum of the distances from two fixed points is a constant. Okay, so your two fixed points are called the foci points, and they are inside on either end of the ellipse. So these are your foci points. And you do have a center point on your ellipse. It's in the middle. Okay, and if you drew a line all the way across that started on your ellipse, goes to the center, goes through each foci, and ends on the other side of the ellipse, those connect the two vertices together. It has two vertices instead of just one like a parabola does. And this line, this whole line is called the major axis. It goes all the way across. So this is your major axis. Now you also have something called the co-vertices on an ellipse. And the co-vertices are on this line segment that is perpendicular to your major axis, goes to the center. And it lies on either end of the ellipse. Okay, so the length of that line is called the minor axis. So the major axis is the longer one, the minor axis is the shorter one. So when you have a vertical ellipse like this and you draw your vertical line, that's your major axis. Okay, so it's the same parts, it's just been rotated around. Okay, you still have your center and your two foci points. Then you have your co-vertices, your minor axis. Any questions so far? So there are all kinds of lengths associated with these different parts. From the center to a focus point, that length is C. They call it C. From a co-vertex to the center, that length is called B. And then from the center to a vertex point, that length is A. And all of those lengths are related. They have an equation that relates all of them together. And that is A squared minus B squared equals C squared. So if you know two of those values and you need to find the third one, you can use the A squared minus B squared equals C squared. And it's the same for either one, horizontal or vertical. Okay, any questions so far? Another thing that's the same is the length of your major axis. It's all the way from vertex to vertex. So the length of the major axis is 2 times A. And that's the same for a vertical ellipse. Then your minor axis length is 2 times B because it's from co-vertex to co-vertex. And your center is whatever your HK is. And that's true for both of those. Okay, so let me write your equations down for you. For a horizontal ellipse, your standard form is x minus h squared over a squared plus y minus k squared over b squared equals 1. Thank you. So this is where your A and your B are used, and your constant value is 1. This is never going to change. That's always going to be equal to 1. A is your larger number. So when it's horizontal, your larger number goes with the X. Okay, the smaller number goes with the Y. When it's vertical, your larger number is going to go with the Y. So your standard form for vertical is y minus k squared over a squared plus x minus h squared over b squared equals 1. Your k is always with the y, h is always with the x. So when it's a vertical ellipse, you need to be careful when you're writing down what the center is. Just make sure h is always with the x, k is always with the y. Okay, so now we get to different formulas because they're lying different directions, so to speak. So if you have a horizontal ellipse, the foci points will be h plus or minus c and whatever k is. Because if you look at the diagram up here, from the center to focus, it's your x value that's changing. So you're going to either add c or you're going to subtract c because there are 2 focus points. The coordinates for the vertices, there are 2 vertices. So those coordinates are going to be h plus or minus a and whatever k is. The distance from the center to vertex is a, so you're going to add that and subtract it to get both the vertices. And you have 2 co-vertices. And this time your y value is going to be the one that changes, so the coordinates for your co-vertices will be h and k plus or minus b. Okay, so for your vertical ellipse, your foci points, the y value is the one that changes. So you're going to keep h the same, and then it's k plus or minus whatever c is, because c is always with your focus. Your vertices is h and k plus or minus whatever the a value is. And then your co-vertices are h plus or minus b and whatever k is. Any questions? Okay, well, let's look at the first problem. It says to give the direction of the major axis, the coordinates of the center, the foci, the vertices, the co-vertices, length of the major axis, and length of the minor axis. Now, you're not going to have to find all of those different things on your assignment. You just need to read the directions. Okay, we're going to do more on these examples than what you're actually going to do on the assignment. So let's look at number 2. Let's go do one that has a different HK value. Okay, so the first thing you need to decide is if this is going to be a vertical ellipse or a horizontal ellipse. And you can tell because your bigger denominator is going to tell you which direction it's going to be. If it's with the y, it's going to be vertical. If it's with the x, it's going to be horizontal. This one, your bigger denominator is with the y, so that means you're going to have a vertical ellipse. Okay, so A is 5, B is 4. I'm going to need those because I need to figure out what C is going to be, and plus I'll get the foci and the co-vertices, vertices with all that. So first thing is to give the direction of the major axis. All right, so this is vertical. Part B says to find the center. Center is going to be -2, +3. Your H is with the X, K is with the Y. Okay, and then on C, wants you to find the foci points. For vertical, it's H and then K plus or minus whatever C is. So I'm going to use the A squared minus B squared to get my C squared. 25 minus 16 is C squared. 9 is C squared, so 3 is going to be C. So my foci points are going to be -2, and then 3 plus 3, which is going to make that 6. The other foci is going to be -2, and 3 minus 3, which is going to make that 0. Okay, on part D, it says to find the vertices. So for a vertical ellipse, the vertices are whatever H is, and then K plus or minus A. So I'm going to have -2 and 3 plus 5, that's 8, and then -2 and 3 minus 5, that'll be -2. And the last thing they're wanting you to find, or almost the last thing, the co-vertices. Co-vertices are H plus or minus B and the K value. H is -2, so -2 plus 4 is going to be +2, and K is 3. And -2 minus 4 is -6 and +3. And then your major axis is 2 times A, so that's 2 units. And the minor axis is 2 times B, so that's 8 units. That's pretty